All right, we're going to go over number 36 on the 2015 June Geometry Common Core exam. We've gone through every problem up till now, and we're on our last one. So let's look at number 36. It says in the coordinate plane, the vertices of triangle RST are R 6, -1, S 1, -4, T -5, 6. Prove that triangle RST is a right triangle. It says the use of the set of axes on the next page is optional. I would always use the axes if they give them to you. So the first thing I would do is go and graph this. I'm going to go on the next page. You have your test there, so you should be graphing this. So 6, -1. Let's go here. And if they don't give you a graph, remember, you have that grid paper at the back of your test that you can always use. Even if they don't give you a grid, if it'll help you, just go to the back and use it. So our first point is 6, -1. All right, I'm going to pause this for a second and calibrate this board. Okay, I'm back. Had to calibrate the board so it's working right, and got that done. So let's go ahead and graph our points. So we have R is 6, -1. So we have this point R, and we have 1, -4 for S, and T is -5 and 6. So we go. Now I'm going to go ahead and make my triangle here. Hopefully do a better job of making these lines than I am right here. I should have a ruler. All right, so we want to go ahead and prove that this is a right triangle. So how can we prove that this is a right triangle? I want you to think about what a right triangle has. It at least has, or only has, one right angle, a 90-degree angle. So how, based on this grid, can we show that there is a 90-degree angle? I want you to think about that for a second. All right, if we have two lines or two segments that are perpendicular to one another, we know that they create a 90-degree angle. So if you look at sides TS and SR, if you can show that those two segments are perpendicular to one another, then you know you have a 90-degree angle. So how can we show that they are perpendicular? Remember, if you have two lines and the slopes are negative reciprocals of one another, then they are perpendicular. Remember, if they are the same slope, they are parallel. Negative reciprocal of one another means they are perpendicular. So let's find the slope of TS. All right, now, looks like that's negative because it's going down from the left to the right. We have our slope formula, which is y2 minus y1 divided by x2 minus x1. So if you want to use that formula, you'd have to choose the point T, and you'd have to choose point S and use the formula there. I think it's easier when you have a grid to just do rise over run and just make your right triangle here on the side. And we know it's negative, so we know it's going down. So that means our rise is actually going to be negative. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So our rise is actually -10. It's going down, and our run is going to the right positive. 1, 2, 3, 4, 5, and 6. So we have 10 over 6, so -10 over 6 for TS. Then if you look at SR, let's find the slope of SR. So we'll do the same thing. This one's going to be positive because it's going up from the left to the right, so we're looking at SR here. So make a right triangle here, and actually I made that wrong. So let me go back, do that again, right here. So we end up with a rise of negative, I'm sorry, not a rise of negative, a rise of +3 and a run of 1, 2, 3, 4, 5, right? So we have 3 over 5, positive 3 over 5. Now, it might not be obvious to you that those are the negative reciprocal of one another. You have to reduce this 10 over 6, this negative 10 over 6. So if you look at that, what number can go into both 10 and 6 evenly? Well, 2. So that would give us, if you reduce it, you end up with a negative 5 over 3. And since they are the negative reciprocal of one another, that means they are perpendicular, which means there is a 90-degree angle there. All right, so we'll take a break for a second. So be right back. Okay, I'm going to show you what you could write here. After you do all this work, you still want to explain how this proves that this is a right triangle. So let's come over here, and you can write down what we have, what I'm showing you right here. It's a pretty good explanation. Since the slopes of TS and SR are opposite reciprocals, they are perpendicular and form a right angle. Triangle RST is a right triangle, as angle S is a right angle. That's a good explanation. We just showed that it is a right triangle. So go ahead and pause it, write that down. All right, now going back, now actually, if you look here, all this work that we did, we actually came over and used the grid. We didn't actually answer the question that's over here. So I'm actually going to erase all this work that we did, and we have to answer this question. What I just had you write, you'd want to write actually here. Right? You wouldn't want to write it over here. Okay? We used the grid, but to answer the question, you want to be back here because we were doing this part of it to prove that it is a right triangle. So make sure you write it in the right place. All right. Also, if you wanted to, you could have actually found the lengths of each side and then plug them into your a squared plus b squared equals c squared to just show that that is true. So, for instance, if you have a triangle that is 3, 4, and let's say 6, and they ask you, is that a right triangle? Well, you can show it by just saying, okay, well, if it's a right triangle, the leg squared plus the other leg squared has to equal the hypotenuse squared if it is a right triangle. And 3, 4, 6, you have 9 plus 16. Is that equal to 36? No, 25 is not equal to 36. That means 3, 4, 6 is not going to give you a right triangle. But if I change this 6 to a 5, and I do 3 squared plus 4 squared is equal to 5 squared. Is that true? 9 plus 16 is equal to 25. 25 is equal to 25. You know that that is a right triangle. So you can do the same thing on the grid. You could find the length of RS, find the length of ST, find the length of RT, and then plug it in and see if it is, if it meets the requirements of a squared plus b squared equals c squared. But so that's another way to do it if you so choose. All right. We'll pause this for a second. Okay, the next part, we are going to, or we're being asked to state the coordinates of point P such that quadrilateral RSTP is a rectangle. So you already have a right triangle down. I'm going to go back and actually do that right triangle again. And we need to find a point P that if you added it to your triangle or put it on the grid, that we could actually have a rectangle. So I'm going to go back and graph this, graph those points again. I forgot I was going to need those. I shouldn't have erased them. But I'm going to go back and graph those. Okay, we're going to state the coordinates of P such that quadrilateral RSTP is a rectangle. So looking here, first of all, if you're looking at this, you should have an idea before you start of where this point should be. We know what a rectangle looks like. A rectangle is always going to be divided into two equal triangles. So you know it's going to be in this general vicinity, okay? If you start having a point that's over here, you know something's not right, because that's not going to make a rectangle, right? So we have to figure out exactly where that point's going to be, though. So if you think about, if you look at S and R, what do you have to do from S to get to R? Well, in order to get to S, or I'm sorry, in order to get to R from S, you'd have to go up 1, 2, 3, and over 1, 2, 3, 4, 5. So if I go over to T and I go up 1, 2, 3, and over 1, 2, 3, 4, 5, I get that point right there, all right? And that's going to be our point we need to make the rectangle. And that's 0.09, but we have to prove it. We can't just say it. So that's 0.09. So make sure and write that point where they ask you to write it. So the coordinates, it says state the coordinates. There are the coordinates of point P. All right, now we have to show or prove that it is a rectangle. All right, so think about what you know about a rectangle and how we can prove that this is a rectangle. Okay, there are a couple of different ways to show that you have a rectangle. Personally, I think the easiest way is to prove or show that the diagonals are equal to one another. And what you can do, or there are a couple different ways to show that. Make sure you understand what a diagonal is. So we have a diagonal here from T to R, and then we have another diagonal from this point P to S. If we can show that these are equal, that they have equal lengths, then we can say, or that proves that this is a rectangle. So let's go ahead and do that. So from T to R, what is the length? So we're going to use the distance formula, and that's going to be y2 minus y1 squared plus x2 minus x1 squared. All right, remember, you need to remember that formula. It's not on your reference sheet. So make sure and memorize that formula. All right, make sure and also pick the correct points. We're doing T to R, so you need to use this point and this point. So we have from -5, 6 to 6, -1. You can go the opposite direction, doesn't matter, just be consistent with your x1 and your your y1 and all that, but it doesn't matter where you start, right? But based on how I have written the points, I'm going to have -5 as x1, 6 as y1, 6 over here as x2, and -1 as y2. So I'm going to have my distance formula is equal to -1 minus 6. That's all squared plus 6 minus a -5 squared. Don't forget to square it. So our distance is equal to -7 minus 6 is a -7. Don't forget to square that. I'm getting students that have negatives under the radical. Should not be that way because you're squaring it. So you should never get negatives in this formula. It's under the radical. And then you have 6 minus a -5, which is 11 squared. So once you square -7, you get 49 plus 121 square root. Don't forget that. So we have D is equal to 49 plus 121. 40 plus 121, 161. 9 plus 161 is square root of 170. Now, typically I have you simplify something like this, but since you're comparing lengths, really not necessary to simplify it. Probably would be easier not to in this case. So TR is square root of 170. Now we need to find the length of the other diagonal. That's what's the other one? The other one is PS or SP. So you have to use the point that you have chosen now. So the one that we found, 0, 9, so we have to use this one and our X. All right, so I'll start at P since it's up top here. So the length of PS, so we're going to do D is equal to, so let me write them here in order, just right next to one another. So 0, 9 and -5, 6. So I'm going to label my X1, Y1, X2, Y2. So I end up with 6. So the square root, don't forget the square root, 6 minus 9. I did something wrong. Let's see. Okay, S, yeah, my S point is wrong. So let me write that again. All right, be careful. My S point is actually 1, -4. All right, so we have, let's see, -4 minus 9. So I have to change this now here. Change this. So this is X2, this is Y2. So I'm going to have -4. Remember, Y2 minus Y1. So -4 minus 9 squared. And plus 1 minus 0 squared. All right, now we have D is equal to -4 minus 9 is a -13. Still squared, don't forget to square that, plus 1 minus 0, so that's 1 squared. So D is equal to, you should know 13 times 13, and negative times a negative gives us a positive, so that's 169 plus 1, and D is equal to the square root of 170. All right, that means our diagonals are the same length. So we can now write, since diagonals, let's see, a lot of ways to write this. Just make sure you convey the message you're trying to get across. Since diagonals TR, don't make a simple mistake now and lose a point. All right, so since diagonals TR and PS and PS are the same length, RSTP must be a rectangle. All right, so that's a 6-point problem, and that's the last problem on the exam. I'm going to start going over a different exam next, so that'll be up pretty soon. But that's the end of this exam, the 2015 Geometry Common Core that was taken last June.